Welcome to the deep dive. We cut through the noise, look at the research, and really try to get you well informed on the big topics changing our world. Today, we're jumping into something that, well, it isn't just theory anymore. It's quietly changing how basically every decision gets made around us. AI decision systems. And this isn't just, tech jargon. It's really fundamental to how organizations, how our cities operate. So this deep dive is for you to help you understand what's happening in your life, your future.
Exactly. And our mission today really is to get past the headlines. We want to pull back the curtain a bit on the architecture, what actually makes these systems work. We'll look at the core technologies, their impact, which is sometimes surprising across different industries, and then tackle those big questions about humans and AI working together. The research we've looked at gives a really thorough picture. It's packed with insights, details that show just how big this shift really is.
Okay, so let's unpack this. This huge shift that's happening. For, decades, businesses use what we call business intelligence, or BI. Think of BI as basically looking in the rearview mirror.
Right.
It's all about understanding what has happened.
Mm-hmm.
You collect historical data, maybe build some dashboards, some reports, and then humans, people like us, would look at the charts, the numbers, and make the final call. It was all retrospective.
Precisely. And now we're moving into something completely different. Decision intelligence, DI.
Mm-hmm.
This is forward-looking. It's action-oriented. Instead of just showing you what happened, DI is focused on what should happen next.
Yeah.
It gives you predictions, recommendations you can act on, and often it even triggers automated actions itself. But the really deep insight here, I think, isn't just that AI makes decisions. It's how our role changes.
Completely.
Well, we stop being the ones making every single tactical decision. We become more like decision architects. We design the systems, we oversee them, we govern them. Think about, say, building a self-driving car versus just driving one. It's that kind of shift in perspective. It's strategic. It means rethinking whole company structures, skills.
Which means retraining, right? Reskilling on a large scale.
Exactly. Massive reskilling. And, this isn't just some IT upgrade. It's way beyond the old decision support systems, the DSS. Those just helped humans decide. They didn't really act on their own.
Okay, so if DI is the brain, let's look inside the engine room. These AI decision systems, they run on some pretty sophisticated frameworks, right? Our sources point to three main technologies powering them. First, AI agents. These are like autonomous little programs for specific tasks, maybe a digital helper for just one customer.
So it's like a specialist, yeah.
Then there's reinforcement learning, RL, where the system learns by, trial and error, like learning a game.
Right, getting rewards for good moves, penalties for bad ones.
Yeah. And of course, large language models, LLMs, they're becoming super important for understanding us, for language, bringing that sort of human-like interaction into the mix. And these pieces often come together in something called a decision intelligence platform, a DIP.
Mm-hmm.
Think of it like a big software suite that connects the data to the action, usually 4 layers. You've got the data layer pulling in all kinds of information, then the intelligence layer, that's the engine doing the analysis, the forecasting, the learning, then an automation and execution layer turning insights into actions, but importantly with human oversight. And finally, the engagement layer. That's the interface, how we interact with it, understand its reasoning, hopefully build some trust.
And digging a bit deeper into that architecture, a really interesting trend is what are called neuro-symbolic systems.
Neuro-symbolic, okay.
Yeah, it's quite clever. It basically blends the pattern spotting power of neural networks, deep learning, with the logic and, crucially, the explainability of symbolic AI. Rules, knowledge graphs, that sort of thing.
Why blend them? Why not just use the powerful deep learning?
Well, that gets to the core black box problem. Deep learning models can be amazing predictors, but sometimes it's really hard to know why they made a specific decision. Their inner workings are just too complex, opaque. And that leads to this fundamental trade-off: performance versus explainability. In high-stakes areas, think finance, healthcare, you just can't afford a black box making critical calls without understanding why.
You need to be able to explain it.
Exactly. So these hybrid neurosymbolic architectures try to give you the best of both worlds: high performance and transparency. It's about building reliable, explainable systems.
Which brings us right back to trust and evaluation. You mentioned oversight, but how do we really make sure these systems are trustworthy? It seems critical.
Oh, absolutely non-negotiable. Rigorous, continuous evaluation is key. A model might look great in the lab on training data,
but fail in the real world.
Precisely. The real world is messy. Unexpected data, subtle biases, maybe even people trying to trick the system. So evaluation isn't a one-time check, it's constant. It becomes an active governance function.
So what does that involve?
Well, several things. continuously checking performance metrics, accuracy, speed, whatever matters, stress testing it, throwing weird data at it to see if it breaks, looking specifically for bias, making sure it's fair across different groups, using special tools, explainable AI or XAI tools to try and understand why it's making the decisions it is, not just what it decided.
Peeking inside the black box.
Trying to, yes.
Yeah.
And then ongoing monitoring, watching out for data drift or concept drift. That's when the real-world data changes and the model's accuracy starts to slip. And even with all that, humans are still the backstop. The human in the loop, providing feedback, handling those really weird edge cases the AI just can't figure out. This whole process gets built into the MLOps pipelines, the systems that manage the AI lifecycle.
Okay, this technical depth is fascinating, but let's see it in action. Where does this get really interesting in the real world? Let's talk sectors. Maybe start with finance and insurance. Speed seems key there.
Definitely. Speed and accuracy are huge drivers. You have algorithmic trading operating faster than humans possibly could.
Milliseconds, right.
Or even microseconds. And AI for fraud detection. Think PayPal spotting tiny anomalies that signal fraud instantly. Then there's underwriting and insurance.
Yeah.
Companies like Hiscox are using AI to quote complex risks in minutes, where it used to take days.
That's a massive efficiency gain.
It is. But zooming out, the bigger picture, and maybe a slightly unsettling one, is how this introduces new kinds of risk. Systemic risks.
How so?
Well, it shifts the risk profile. It's less about individual human error and more about the emergent behavior of this whole ecosystem of algorithms interacting. Think about flash crashes, where autonomous trading agents react to each other and cause huge market swings almost instantaneously.
A sort of digital chain reaction.
Exactly. Unpredictable, high-speed, systemic risk.
Okay, what about healthcare? Personalized medicine is the buzzword there.
And AI is a huge enabler. Moving away from one-size-fits-all, we're seeing AI assist in medical imaging, helping doctors spot things in scans, subtle things that might be missed.
Improving diagnostics.
Significantly. And predictive patient monitoring, using AI to anticipate problems, which studies show can cut hospital admissions and even help patients stick to their treatment plans better. We're talking improvements of 18%, 22% in some cases.
That's impressive. But healthcare data is sensitive.
Extremely. And that's the clash, right? You have strict privacy rules like IPA, but AI models, especially deep learning ones, need enormous amounts of data to train effectively.
So how do you square that circle?
Well, this is driving innovation in privacy-preserving techniques. Federated learning is a great example. The AI model kind of travels to the data, learns locally on, say, a hospital server.
Without the actual patient data leaving the hospital.
Exactly. It only sends back the aggregated learnings, the updated model parameters, not the raw, sensitive data. It's a way to collaborate and build better models without compromising privacy.
Clever. Okay, let's switch gears. Logistics and supply chains. We all felt those disruptions recently. Can AI help make them more resilient?
That's precisely the goal. Moving from those hyper-efficient but brittle just-in-time systems to something more adaptive. AI is getting much better at demand forecasting. McKinsey reported error reductions of 30–50%. That means companies can anticipate needs way more accurately.
And presumably optimize operations, too.
Absolutely. Warehouse automation, look at Amazon with their robotics, massive speed increases.
Yeah.
Road optimization for delivery fleets, cutting fuel use, improving on-time rates significantly, like 20–35% improvements aren't uncommon.
So it's not just about cutting costs anymore.
No, the strategic focus is shifting. It's moving from pure efficiency to data-driven resilience. AI lets planners model really complex scenarios, trade-offs between cost and robustness. BMW's use of digital twins is a good example.
A virtual copy of their factory.
Essentially, yes. A sophisticated simulation where they can test things, optimize workflows, plan for disruptions, all virtually before implementing changes in the real world. It builds resilience.
Makes sense. Then there are autonomous systems, self-driving cars, smart cities. AI is obviously central there.
It's the core intelligence. For autonomous vehicles, AI handles perception, seeing the world, making decisions in real time, planning the path. But it goes beyond cars. Cities like LA, Pittsburgh, Seattle are using intelligent traffic management systems, AI optimizing signal timings, rerouting traffic. They're seeing travel times cut by up to 25% in some corridors.
Wow.
And it extends to public safety, too, things like predictive policing, though that's controversial, and real-time video analysis. Also, sustainable urban planning. Smart grids, waste management optimization, even those digital twins for whole cities, like Las Vegas is building.
But this feels like an area where the rules haven't caught up.
You've hit on a key issue, the governance gap. The tech is moving so fast, our laws, our ethical frameworks, they're lagging behind.
Leading to big questions.
Huge questions. Who's liable if a self-driving car crashes? How do we prevent bias in predictive policing algorithms? How do you hold a black box accountable when it makes a critical civic decision?
So what happens?
Well, I think we can anticipate a kind of smart pause in some areas. Growing demands for much stricter auditing, more transparency, clearer standards before we see really wide deployment, especially in public spaces.
Okay, let's shift to something maybe a bit lighter, but still huge. Media and entertainment.
Ah, the hyper-personalization engine.
Right. Recommendation systems. Netflix, Spotify, YouTube. They guide so much of what we see and hear. One source said recommendations drive almost a third of the market share.
It's massive. And it's not just recommendations. AI is increasingly assisting in content creation itself, writing scripts, generating images, composing music.
But does that hyperpersonalization have a downside?
It certainly can. The filter bubble effect is real. If the algorithms only ever show you things you already like, or things similar to what you've already seen.
You end up in an echo chamber.
Exactly. Your worldview can narrow. You miss out on serendipity, on discovering something completely unexpected and different. So the strategic challenge for these platforms becomes, how do you balance that incredibly effective personalization with, let's say, engineered serendipity? How do you still surprise and broaden users' horizons?
That's a fascinating challenge. One last sector. Climate science and sustainability. Can AI help here?
It's becoming a critical tool, actually. AI is being used to improve the accuracy of complex climate models, predict extreme weather events with greater lead time, and optimize resource management.
Like managing energy grids.
Yes, optimizing renewable energy integration into the grid, making agriculture more resilient to climate impacts, managing water resources more effectively.
But isn't there a paradox? Doesn't training these huge AI models use a ton of energy?
That is the AI energy paradox, and it's a serious concern. Training a single large AI model can have a significant carbon footprint. Generating one complex AI image might use as much energy as charging your smartphone fully.
So AI helps fight climate change, but also contributes to it.
Precisely. Which is why green AI, or sustainable AI, is becoming a major focus for research and engineering. How do we build powerful AI systems much more efficiently? It's a critical challenge for the future.
This brings us back to the human element in all of this. It sounds like the future isn't really AI replacing humans, but more like humans and AI working together, a symbiosis.
That's definitely the emerging consensus, yes.
Yeah.
It's about collaboration.
Right.
AI has clear strengths, processing vast amounts of data incredibly quickly, consistency, spotting patterns humans might miss, especially in well-defined areas.
It doesn't get tired or bored.
Exactly. But humans bring different strengths to the table. Contextual understanding, common sense, which is surprisingly hard for AI, ethical judgment, adaptability, especially in completely new situations where there's no data, creativity, emotional intelligence.
Things AI struggles with.
Absolutely. When you face a truly novel problem, human intuition and adaptability are still crucial. That's why this idea of human in the loop, or HITL, isn't just a temporary measure. It's seen as a long-term strategic need for safe, effective AI.
So why exactly do we need humans in the loop?
Several reasons. Handling ambiguity, those weird edge cases AI wasn't trained on, providing essential ethical and moral oversight. AI doesn't have values. Building trust is another big one. People are often wary of algorithms making important decisions, what's sometimes called algorithm aversion.
And accountability, presumably. Someone needs to be responsible.
Precisely. But what's fascinating here is something called the human oversight paradox.
Okay.
Research shows that sometimes the explanations generated by AI, even if they're meant to help, can actually unduly influence the human overseer. People might trust the AI's reasoning even when it's flawed.
So the explanation itself can be misleading.
It can anchor the human's judgment. It highlights that effective human AI teams need humans to be critically engaged, not just blindly accepting the AI's output.
That makes sense. And are there still big unanswered questions here? Open research problems in making this collaboration work?
Oh, definitely. Big ones. Like truly understanding human AI complementarity. When exactly does a human plus an AI outperform either one alone? What are the specific conditions? Think maybe AI flags anomalies on a medical scan, but the human doctor uses broader judgment for the diagnosis. We need to map that out better.
What else?
Understanding and shaping how people think about AI, their mental models. If you think AI is perfect, you might over-rely on it. If you think it's useless, you won't use it effectively. So how do we design systems that help users build an accurate understanding of what the AI can and can't do, like the displays in an autonomous car need to clearly show its limits?
Right, managing expectations.
Exactly. And finally, developing effective ways for humans and AI to interact. How much information should an AI provide? When? Confidence scores can help, but bombarding someone with data leads to cognitive overload. It's about designing interfaces like in clinical decision support that give just the right insights at the right time without overwhelming the user.
This all really scales up to the bigger societal picture, doesn't it? And it starts with, well, you called it an ethical minefield.
It certainly has that potential.
First up is algorithmic bias. You mentioned this. It's not usually deliberate malice, right? It's more systemic.
Often, yes. It can creep in from the data used to train the AI. If the data reflects historical biases, the AI will learn them. Or it can be in the design of the model itself, or even emerge from how humans interact with it, like that automation bias, where we just trust the machine too much.
And this can have real consequences.
Absolutely. Facial recognition systems performing worse on darker skin tones, for instance, or bias in systems used for loan applications, hiring, even military targeting. It's a huge problem that requires constant auditing and specific techniques, fairness-aware machine learning to mitigate.
Then there's the black box problem we touched on, the lack of transparency.
Right. If you can't understand why an AI made a decision, it's incredibly hard to debug it if it goes wrong, to audit it for bias, or, frankly, for people to trust it.
Yeah.
Especially in critical fields. This is the driving force behind explainable AI, XAI research, trying to make AI reasoning more transparent.
And finally, accountability. This seems incredibly tricky with autonomous systems.
It's a crisis, really. If an autonomous system causes harm, think that self-driving car accident again. Who is responsible? The owner, the manufacturer, the software team, the company that supplied the sensor data. Without clear lines of responsibility, it's incredibly difficult to assign liability or ensure justice.
Okay, shifting from ethics to economics. This transformation, it must be causing economic disruption, job displacement.
Unquestionably. The World Economic Forum has projected tens of millions of jobs potentially displaced by automation in the coming years. We're seeing it already.
Which kinds of roles?
Roles heavy on routine tasks are often first in line. Administrative support, customer service centers, some financial analysis roles, transportation like trucking, and now with generative AI, even aspects of content creation, coding, legal research. IBM's Ask HR tool replacing some HR functions is an example.
And does this affect everyone equally?
Likely not. There's a real risk of widening wage inequality. High-skilled workers who can design, manage, and work with these AI systems may see their value increase, while those whose tasks are automated might face wage stagnation or displacement. It could also worsen geographic disparities. Tech hubs might boom while other regions struggle.
So what's the path forward?
It has to involve massive investment in reskilling and upskilling the workforce. Lifelong learning becomes essential. Supporting entrepreneurship, too, helping people create new kinds of jobs and businesses enabled by AI. It requires proactive policy and investment.
Which brings us to regulation and governance. This can't just be left to chance.
Absolutely not. Strong governance is crucial, both within companies and at the public level. Organizations need their own AI governance frameworks, clear ethical principles, risk management processes, accountability structures, transparency commitments, compliance checks.
And governments are stepping in, too.
Yes, major frameworks are emerging. In the U.S., there's the NIST AI Risk Management Framework. It's voluntary, but provides a solid structure around governing, mapping, measuring, and managing AI risks, aiming for trustworthy AI.
And in Europe?
Europe has taken a bolder step with the EU AI Act, approved just this past May 2024. This is the world's first comprehensive, legally binding AI regulation.
How does it work?
It takes a risk-based approach. Some AI applications deemed unacceptable risk are banned outright. High-risk systems used in critical infrastructure, employment, healthcare, etc., face very strict requirements for data quality, transparency, human oversight, and robustness.
Yeah.
Then there are lower tiers with lighter obligations.
And it has teeth.
Oh, yes. Penalties for non-compliance are severe, up to $35 million or 7% of global annual turnover. And importantly, it has extraterritorial reach. If an AI system affects people in the EU, the rules apply, regardless of where the company is based. Much like GDPR did for data privacy, the EU AI Act is really setting a global benchmark for AI regulation.
So wrapping this all up, what's a big takeaway? Where are we heading? It feels like a clear trajectory. More autonomy in systems, hyper-personalization everywhere, operations becoming increasingly predictive, and our role as humans shifting towards being these decision architects.
I think that's right. And the key insight, perhaps, is that the real value isn't going to come from just replacing human judgment wholesale. It's about augmenting it, making us collectively better, faster, more capable. The biggest hurdles aren't just the technical ones anymore, they're societal.
Yeah.
The ethics, the economics, the governance, getting that right is the central challenge.
So, as these AI decision systems weave themselves deeper into our lives, deciding loan applications, managing city traffic, maybe even influencing medical diagnoses, here's something for you to think about. What personal responsibility do you think we all share? What responsibility do we have to demand that these incredibly powerful systems are built and used in ways that are not just efficient, but also fair, transparent, and ultimately aligned with our human values?